Hi, boys and girls. All right, so this video shows a really fun and easy activity that you can do with gravity. So if you just have two different bouncing balls at your house, then you can do this. And this will be another one that if you want to do it and share a video, you're welcome to. And I would challenge you this week that when you do the video, try to explain the science behind what is happening, and let's see how much you're learning. All right, so this is an oldie but goodie. I've used it every year for a long time, and it's just really, really fun. We've always done this experiment in class with people bouncing the balls, but you can easily do this at home without spending any money or making anybody stressed out. So I encourage you to try it, or if not, that's why we got the video. All right, let's watch.
I want you to make a prediction. In my left hand, I have a standard-sized basketball, and in my right hand, a 5-kilogram medicine ball. If I drop them both at exactly the same time...
Now, I've never seen a medicine ball before, but I feel like it's something that people use in the gym when they exercise, and it weighs a lot more than a basketball. So same shape, almost the same size, but very different masses. All right, and this video is going to be talking to you about the connection between gravity, inertia, and mass. So it's really cool.
Which one will hit the ground first?
Now, do you know which one would hit the ground first? Would it be the heavier one that hits the ground first, or would it be the lighter one that hits the ground first? And I should say, is it the one that's more massive or the one that's less massive? Would something more massive be pulled down to Earth faster? Would something less massive be pulled down to Earth slower? Would they happen to hit at the same time? And if so, why is that? Why would they hit at the same time, or why don't they? Now, it's all about you predicting, and you get to see some of these like grown-up kind of college kids do a little predicting of their own.
This is a trick one, isn't it?
The heavy will go down first.
Well, yeah, it'll drop faster. They'll both hit the ground at the same time.
Give me a prediction.
I actually would have thought this one would go faster because it's heavier.
Maybe it's that one. Maybe this one, yeah.
So you reckon this will be
I reckon
faster?
that one would be faster.
So, why does that make it go faster?
Because the weight pulls it down quicker.
What are we measuring when we say, oh, it's heavier? What are we feeling?
Gravity?
Go ahead. Yeah, that's... Oh.
Objects being pulled to the earth, I guess.
Okay, so which of these objects is being more pulled to the earth?
This one.
That one, the black one.
All right. Well, here's what we're going to do. I want you to hold both of those above your head. Can you get them really high? Can you? Okay, on the count of 3. Ready? 3, 2, 1.
Yeah! Exactly the same.
Oh, they fell at the same time. Exactly.
So what do you think? Do they hit at different times, or do they hit at the same time? To me, it looks like they're hitting at the same time. So...
Same time.
They hit at the same time.
Was that what you expected to see?
No.
So what do you make of that?
I need to go read more books.
Magic? Gravity is going to pull at the same rate, no matter how heavy or how light it is.
now, based on that experiment, would you think that gravity pulls at the same rate no matter how heavy or how light it is? Now, it stands to reason that if you are on Earth, right, everywhere on Earth would have the same amount of gravity pulling down. If you went to a different place with less mass, then you would have a more intense gravity pulling in. Less intense gravity pulling in, sorry. But why do these things fall at the same time? Maybe it's just because the gravity is the same. But when the person was holding the heavy ball, that person was saying they could feel gravity pulling harder. Huh.
But gravity is how light or how heavy something is.
It's one big massive mind. There must be some force that's dragging them down, and actually the actual weight of it doesn't matter.
Something to do with mass or something.
I can't remember why.
It's almost like the weight holds it back in a way, even though that doesn't seem to make sense.
I think she just got it. She says the weight holds it back. What would it be if there's something that's holding it back and keeping it doing what it's already doing? What's that called? When a tendency, a tendency that things keep doing what they're already doing? Are you getting it? All right, let's see.
You might be hitting on an interesting point there. Weight holds it back. Now, it's not actually weight that holds it back, but inertia.
Did you guess inertia? The tendency to hold it back, right? The tendency for something to keep doing what it's already doing.
The tendency of matter to maintain its state of motion. so to remain at rest if stationary, or to continue with constant velocity when in motion.
What's the big idea?
The big idea is this one has more mass, so it's got more weight, which you can clearly feel, but it's also got more inertia, which means it's also more sluggish.
Right.
It tends to resist acceleration. So that greater force is required to accelerate it at the same rate as this ball.
So did you hear that? There was Newton's second law in there too. That would need more force to make it accelerate at the same rate as the other one because there's also more inertia holding it back. So blowing your mind. All right, so now the one that's heavier is being pulled harder. It's like it's being pulled more because it has more mass. But because it has more mass, it also wants to keep doing what it's doing. Just like the plates on my table, they wanted to stay right where they were. Something with more mass wants to stay doing what it's doing, and because of that, it's like the inertia of the object balances out the fact that it's heavier when gravity is pulling it down, which is super weird and super freaky.
Like a heavy car trying to accelerate.
Like a heavy car trying to accelerate, you need more force to get it going.
Yeah.
Exactly. So what is all that?
So when she said that, that reminds me of like bigger cars, like a big old like a Hummer, right? It takes a lot more fuel to be able to use it. It gets worse gas mileage because you have to use more fuel in order to make it go the same distance that a lighter car would go. So like littler, lighter cars are easier on the gas because it doesn't take as much fuel to propel it forward because it doesn't require as much force to make a tiny car move.
That mean? Well, the force on the medicine ball is greater than the force on the basketball, but it has more inertia. And what's really important is that the ratio of force to inertia is the same for all objects. So everything accelerates at the same rate and lands at the same time. The plastic block, because it's conducting the heat to the ice cube faster.
All right, so that was pretty cool. And all you need to do is, if you decide to do it, go outside, get 2 balls, get a basketball and a soccer ball or whatever, and drop it and video yourself dropping it and see if you can explain how the mass might be different, right? But when something is heavier, it also has more inertia holding it back, which is why they hit at the same time. See if you can explain that on your own. It's pretty cool, and I know you can do it. And if you get mixed up, who cares? We're learning. All right, love y'all. Go try it for yourself.